Morning, everyone. My name's James Matchett. I'm the head of security at Cloudsmith, and I'll be chatting about the AI's impact on an already quite fragile supply chain. I've been at Cloudsmith for a year. I had my first anniversary on Tuesday, and my main driver is just end-to-end security. Outside of work, I put in quotation marks, I love pen testing, 3D printing, electronics. I've been described as a nerd's nerd, and I used to do some curating here at Beltech and NIDC. Cloudsmith is a 150-person Series B funded scale-up founded in Belfast, founded by Lee and Alan in 2018. We serve some pretty big customers like American Airlines and Shopify, but we've got some Belfast logos as well, like Aflac and Bazaar Voice, and we'd love to see some more. We sit in the middle between the open source supply chain and your development endpoints, your build infrastructure, and your production servers. If a package comes through us, we scan it, we apply policies, we analyze the metadata. I could talk for hours about the engineering that goes into this, but essentially packages go up, magic happens, packages come down. And the word magic is doing some heavy lifting there. I've only got 15 minutes, so I'll try to be brief. I'm going to explore the fragility of the current supply chain. We'll talk about some risks of AI in this context, chat about stop squatting, some real-life examples, and some practical guidance on what to do about it. And if by the end of this talk I can make at least one engineering manager run out in terror and tell their team about some risk, I've done my job well. So from the basics, there's two types of package. There are direct dependencies and there are transitive dependencies. If you install a package, let's say pip install requests, you don't just get requests, it brings some stuff along with it. For instance, if you had coffee today, you didn't just have coffee, you had beans in there, there's a filter, probably a grinder as well, and all of these have different versions that depend upon each other. It gets messy very, very quickly. For instance, if you install requests, you have 6 top-level packages, and at the third level, you have about 75, all with codependent versions. Any one of these could have a vulnerability, been recently updated with malware, and most developers don't even know that it's on their machine. This XKCD comic is basically the North Star at Cloudsmith. This gets mentioned pretty much every single day. Our perspective on software is it's not as much written as it is assembled out of components, pre-existing libraries and reused code. And the hidden danger here is not the packages that developers are directly pulling in, it's the transitive or transient dependencies that go unchecked. The median package count for an NPM project is 600 packages. Who thinks the developers have actually gone into each one of those and checked it to make sure they're safe? 74% of code bases on the open source internet today have high or critical vulnerabilities, and that's just from the packages they bring in, not the code that they've written. I did a little bit of querying using Google BigQuery. They have a data set from July of 2025. Hopefully it's not too small, but I tried to find the bus factor of popular projects. Who here knows what bus factor is? A few hands. Essentially, it's if someone on your project got hit by a bus, how much trouble would you be in? HR prefers the term if they win the lottery or go on holiday. So I tried to find which projects would be in the most trouble. I've taken projects with 100 stars or more, and only 8% of these in PyPy are at danger of this. But it's still basically 1 in 10 of your projects could be in trouble if there's a critical dependency, a vulnerability, and it's code that you can't change or write yourself. Now, bus factor is cool, but we're here to talk about Armageddon, the dominoes falling, packages and services going offline. If you instead look at two things, the direct dependencies and the blast radius of transient dependencies, it gets a lot worse. And just to take the top example of NPM's R flatten, which is what sounds like if a pirate tried to make an NPM package, it has 2 contributors, 37 stars on GitHub, nothing to scream about. 190 projects directly depend on it, but 400,000 projects bring this in as a transient dependency. If I was a threat actor, I'd be looking at projects like this to try and take over, insert malware, and to take over the world. If you do this by percentage of the ecosystem, it's about 40% of the NPM ecosystem uses this package. And if you're wondering why some of them are above 100%, supply chain is so messy that the same package can be brought in multiple times by a transient dependency. So just a quick pop quiz to sell this point. If you made a brand new Next.js project, how many dependencies would you have? Any guesses? 500? So at the very top level, you have 18 direct dependencies, 18. One layer down, 103, next layer down, 287, and by the time you get to the bottom, 912 packages are in your code base and you've written 0 lines of code. Any one of these could have a vulnerability that takes your service offline. There's 3 really good examples of where this happened in the world. LeftPad in 2016, it's actually so small, it is in that thumbnail up there, 11 lines of code, and all it does is change the string slightly. That was deleted out of anger by the developer, and it took out Facebook, it took out PayPal, it took out Reddit. Everyone's quite famous with Log4j. I think a few people here must have responded to this around Christmas time in 2021, and this just highlights the risk that if a defect is in a really common library, it is everywhere. A lesser known one, but still just as devastating, was XC in 2024. A maintainer came on the scene to try and add some new features to a pretty common Linux file compression utility, and they hid a backdoor in the test file, which would have granted them SSH access to any machine that was running an up-to-date build. Who's scared yet? So I've been talking for 5 minutes in an AI talk. Sorry, I've been talking for 5 minutes in a talk about AI without mentioning AI. This is how fragile things are with humans just doing human things. What if we hit the gas pedal and bring AI into this mix? If this is our North Star, this is what I think AI does to it. I miss Angry Birds. So some facts and figures. AI is a tool, and we first have to look at how AI is actually being used by people. 80% of new developers in GitHub use Copilot within their first week of having a GitHub account. There's currently 36 million people using Copilot free currently. 76% of companies who were audited by Black Duck that had policies against their developers using AI admitted they knew it was being used anyway, and there wasn't much they could do about it. Code complexity in projects is going up year on year. In 2024, the median file count for a project was 16,000 files. This has gone up to about 21,000 now, which makes projects harder to maintain and harder to audit. This is mostly due to AI having a preference to bring in libraries, but there's also a shadow risk here, which AI likes to try and take snippets from projects and adds it in. You now have that project in your code base, but it's not showing up on any SBOMs, you can't upgrade it, and if there's a defect, you're in trouble. And lastly, 29% of known exploited phones were exploited on or even before the day of disclosure. The day of disclosure is when the public finds out that a vulnerability exists, and that's when you start patching. The fact that 29% of these are exploited either on the day that it's disclosed or before means you're already in trouble. The count of CVEs is going up. We're expected to have over 50,000 this year. That's about 130 a day. Now, those are just submitted, and they're not all accepted. Some are rejected. But 130 a day, manual patching doesn't work. I looked at Stack Overflow's AI survey of developers. They just asked developers how they're using AI. And we're starting to see them adopt it a lot more. And there's kind of a lukewarm approach to the accuracy of AI. It's starting to get up there as models become more accurate and make less mistakes. This was done in 2025, and I'm sure the mood of the room is much different since. The poll that stunned me the most as a security guy were these questions here. And unfortunately, I can't read this. So AI solutions that are almost right, but not quite right. It's hard to understand how or why the code works. I've become less confident in my own problem solving or the answers the developers are giving today, or rather in July of 2025. And as a security guy, that terrifies me. If you can't understand the code, you can't secure it. It's as simple as that. And even worse, if it looks fine and it runs fine, but actually isn't fine, it's a disaster waiting to happen. We did our own surveys on our side, and it seems about 42% of developers are saying about half of their code base is AI generated, about half. And this introduces a new thread of attacks. These are the same old attacks coming in, but with an AI twist on them. And this is a familiar one called typo squatting. Some people may have heard of it before, but you take a popular package that everyone uses, you swap 2 letters around, and you hope someone typos it. They install the wrong package, and suddenly your code is running on their machine. The equivalent of this in the AI world is slop squatting or typo squatting, and I tried to think of a good AI image equivalent of this. And the truth is the same. You request a package, and you get something that looks kind of similar, but not quite the same. I could tell a difference, but I'm not sure about everyone else in this room. And it might look a little bit like this instead, where you order your Guinness instead of your Guinness, or your Beamness instead. But it looks a bit like this, where we're looking for where AI gets the name of a package ever so slightly wrong, and we can take advantage of that as attackers. I had to throw in one Simpsons meme just to take a break and take a breath. So this is how this works. Slop squatting. I'm an attacker. I speak to an AI model, and I ask it coding questions. I look at the responses it gives me, and if it ever gets a package name wrong, or suggests a package name that doesn't exist, I go and register that package myself. Then whenever a legitimate user comes across and tries to run, let's say Copilot, and takes that hallucinated answer, they install that package, and their machine is mine, their build process is mine. Now, there's no one model which is more predominantly susceptible to these hallucinations than others, But certain questions around bundling, grouping, combining packages together tends to make them hallucinate a lot more. 8.7% of AI hallucinated Python package names are actually valid package names in JavaScript. And typically, whenever a model hallucinates a package name, it does it consistently. So if I ask a question as an attacker and it hallucinates the name, I can guarantee if a legitimate user asks a similar question, they'll probably get the same hallucination. In 2023, this affected the Hugging Face CLI. Hugging Face-CLI is the command for actually using it, but someone went and made the package based on the AI hallucination. And within 3 months, this was thankfully a security researcher doing no harm, just seeing how many people would actually pull it. They had 30,000 downloads. But a really interesting effect was, this was added to the README of an Alibaba repo. And whenever the AIs went to do their model refresh or their knowledge refresh, it then actually started suggesting this as a legitimate suggestion, no longer a hallucination, a legitimate suggestion. Now, if you know statistics in AI, that's two sides of the same coin, but the prevalence is much higher. There's one other type of attack I want to cover very quickly, which is dependency confusion. And this is where you have a private internal registry of packages. You then, let's say as an attacker, find some open source code related to that company, and you notice that they haven't registered that package name publicly. The default configuration of the majority of endpoints is to check public indexes first. So I can take an internal package name, which is held and hosted privately, make it public by naming it myself, and suddenly I have code access to your developers. And this has affected companies like Google in the past, who famously said they wouldn't pay out the bug bounty for this. Who here's heard of Shy Halud over the past few weeks? A few people? This popped up in about September of last year, but there's a few different iterations that have happened since. And this is arguably one of the scariest bits of malware, because it actually uses the supply chain to deliver the malware. It might be a bit hard to actually see the attack chain here. Essentially, it begins with phishing maintainers of NPM packages. You send them an email saying you've got to reset your NPM credentials. They get phished. The attacker then distributes their malware using the NPM supply chain. And this is where the dependency thing comes back in. If any projects are dependent on a compromised package, they too eventually become compromised. It then steals the GitHub tokens or the NPM tokens of the developer who got attacked. And quite interestingly, it's actually using TruffleHog now, which is a legitimate security utility for finding credentials, to discover credentials itself and steal them. So what can we do about this? Start with training your developers on how to use AI well. Be skeptical of what's produced. Stick to your testing flows. Don't bypass them because Copilot's always right. And if you don't understand it, don't merge it. It's a tool. Use it as such, not a replacement for scrutiny. And consider guardrails. I've heard some mentioned today so far, such as defensive prompting, restrictive model permissions, or single repository contexts. But this only really supports the code that developers are looking at, not the libraries that they're pulling in and not even reading. How many developers here could honestly say they read every line of code of every project they bring in? And what if there's a vulnerability? What if something malicious has been inserted since the last update? If it's already been pulled to your machine, it might be too late. If it's being deployed, it's definitely too late. The diagram on the left-hand side is the standard attack flow. It starts with reconnaissance, you get initial access, you do privilege escalation, lateral movement, and then you eventually do your actions on target. And that's stealing data, stealing credentials, spreading further. That hasn't changed much over the past 5 years. What has changed is the timeline on the right-hand side. 5 or 6 years ago, you would have a comfortable 30 days to patch something after the disclosure came out. 3 years ago, you'd have about 3 days. And today, you'd have about 24 hours if you're lucky. As I said, a quarter of these disclosures are already being attacked before the disclosure comes out. So some final practical organizational guidance for the CISOs and CTOs in the room. Verify your packages. Make sure whenever you install a package, it's actually what you want. Treat adding or upgrading packages in a project as a privileged operation. Have predefined policies on what is an allowed package and what is not. And have good AI guidance and review what's generated. To secure what you have, scan for CVEs and malware by default. Have a strong remediation policy that's automated where possible. Log which packages are pulled by who when. That is gold dust in an incident. For Log4j, I had to look for who pulled the hashes of those. We didn't have any SBOMs or anything at that time, and it got messy. And approval gates for new packages entering production just makes sense. Consider a private repository so you don't have dependency confusion, and train your devs on how to do this well. AI is just a tool. Teach engineers and new developers on how to use it, but the drawbacks are such as well. I'm encouraging my teams to use AI. We need to find out what's out there. if we don't understand how developers and engineers are using AI, we've got zero hope of telling them how to use it securely. So with 19 seconds left, that's me. Thank you very much for your time, and have a great day.